welkom. De laatste mensen binnenlopen. Ja. Dus ik ga mijn uiterste best doen om jullie de komende 40 minuten te vermaken met een beetje een alternatief verhaal over hoe hou je de band samen. Dus je werkt in een ontwikkelteam en je hebt een team met allemaal geweldige jongens en meisjes samen. Toffe dingen aan het doen. Hoe zorg je dat je de band zo lang mogelijk bij elkaar houdt? Ik ben Eppo van Plas, ik ben een engineering manager bij ASML. En vooral binnen ASML is dat stable teams concept knijterbelangrijk. Vooral omdat het mij typisch 6 tot 12 maanden duurt voordat een ontwikkelaar eigenlijk goed geonboard is, voordat iemand up and running is met het begrijpen van hoe is nu het probleem. Oh shit, I should do this in English, right? No worries. On how am I contributing to solving the problems for our customers? So we will start a bit about with a bit of nerding out about the semiconductor industry because it has some really interesting aspects to it, and we will transfer in how software is a very important part of ASML, and then how we can keep these teams stable. I love a bit of interaction, so feel free to interrupt me with any questions or opinions for that matter. I will try to keep an eye on the room as well. For sure, there will also be some room for questions in the end. But I love a bit of interaction. Also, be prepared. I will try to ask you some questions in the meantime. So the semiconductor industry, right? Semiconductors, the building blocks, the elements that build transistors. The transistors, the tiny switches that make our code run. The computer chips, right? They are everywhere. And nowadays, they are incredibly complex three-dimensional structures. So if you look at the animation behind me, then it gives a bit of an impression of the complexity involved, right? So you have these multi-layered structures, these vias connecting all kinds of layers, and this all together gives us a computer chip. If you look at the semiconductor manufacturing process, it is quite a complex process. So typically we start with slicing and polishing the silicon cylinder, depositing the material, the photoresist, exposing an image, developing and baking, then etching away the photoresist, doing the ion implementation, removing the remainder of the photoresist, and then you have a processed wafer. This step is repeated over and over again, and for some of the advanced nodes, they have up to 100 or more layers, right? Especially with DRAM or the high-end logic nodes. We can have up hundreds and hundreds of layers. So it takes quite some time to really construct a computer chip. That's also why the wafers, in the end, they represent a tremendous amount of value, because there can be hundreds of chips on the wafer, the big silicon disk, and it takes quite some time to process. So we've come quite far since the beginning, 60-ish years ago, 1959. Fairchild, the first transistor integrated circuit on silicon. And today we can have billions of transistors on that exact same square area, literally billions of transistors. And this is driven by Moore's law, which, as we are all engineers, most of you will know. It's been around for over 50 years, and it's still more or less valid today, and that's a very good reason, because it's a law of economics. So for instance, if you take The Hitchhiker's Guide to the Galaxy, the book by the late great Douglas Adams, and it's printed on a 14 size of font, it typically takes about 227 pages. Now if you're able to reduce the font size to 17, you will be able to print the same information on half the real estate. So you've halved the cost of printing the book, you also halved the time it took to print the book, and you doubled the information density. And that is kind of why Moore's law is still around today, right? So more compute, more efficient compute on the same real estate. Now, this has gone pretty extreme to the extent that the structures of where we are today, the slide shows 6 nanometers, but recently in the news was that the 3 nanometer node was already shipped by one of our clients. So you're talking about a 2500th, the size of a red blood cell, right? So that's the scale at which we are operating, at which we are trying to help our customers mass produce chips. It's not only the miniaturization that makes this field incredibly complex, it's also the gate architecture, right? So if you look at the first transistors on the chip, it was very much a two-dimensional structure. Nowadays, with FinFET or even beyond, we have these 3 advanced three-dimensional architectures. So it's not only the miniaturization, it is also the architecture that is changing. Now, ASML in this, our humble beginnings started about 40 years ago in Barrack as a spin-off or joint venture between Philips and ASMI. 31 employees with a can-do, will not take no for an answer kind of attitude, and a lot of perseverance to where we are today, which more or less, or not more or less, actually all of the major chip makers use ASML technology because it's the only technology you can use to make the really high-end nodes, the high-end chips. Biggest European tech company by market cap, and on an annual basis we spend about 3 million on research and development. Close to 40,000 employees, and the number that makes me incredibly proud is the 140 plus nationalities we have at ASML. So it's an incredibly rich and multicultural environment. So the company is well known in the tech industry for creating these advanced machines. And they are truly marvelous pieces of engineering. So just in an open view, in a nutshell, you have a light source, on top you have a mask, a pattern, and on the bottom you have the wafer on which the chip is being projected. You can talk about these machines for weeks. I'm going to highlight one specific detail because it's my favorite, and it's a marvelous piece of engineering, which is the light source of the latest generation of EUV machines. And that light source, you can see it in the animation. We fire a droplet of tin at about 100 meters a second, 360 kph. We hit it with a small laser, which deforms the droplet, and then it turns into a pancake shape. And then we hit it with a big CO2 laser, and the droplet evaporates. During that phase of the evaporation, it emits a plasma kind of light, a plasma light. And that light we capture, and we use that light to project the image on the chip. Now, we need to hit that laser, that droplet. We fire 50,000 droplets a second. So we have an incredibly powerful laser hitting a tiny droplet of tin 50,000 times a second. And the first question I have to you is, where do you think that our laser will fit in that spectrum of the laser pen versus the defense capability? Any guesses? Yeah, I see some fingers pointing to the right. Yeah, that's good, right? 25 kilowatts, right? So instead of shooting drones out of the air, we hit a microscopic droplet of tin with a 25 kilowatt CO2 beast of a laser. Cool. Now, why do we go to these extreme lengths in pioneering light sources? It has everything to do with wavelength. So if you look at our traditional systems from the very first machines like the PAS 2000 to the still very much current today immersion machines with the 193 nanometers, you see with EUV we are at a wavelength of 13.5 nanometers, which is almost, sometimes we call it soft X-ray, but that sounds a bit dangerous, so we like the term extreme ultraviolet, that sounds a bit cooler. So we go to these extreme lengths because wavelength is extremely significant in the feature size you can print on a chip. So this is the Rayleigh criterion, and it dictates that the critical dimension, which is the feature size on a chip, is defined by a process constant K1 multiplied by lambda, which is the wavelength of the light, divided by the numerical aperture of the system, which is more or less the optical specification. So obviously, the smaller your lambda, the smaller your structure on the chip. So as you see more or less a linear reduction in feature size, you see an exponential increase in complexity of the machine. And this is where software comes in, right? So more and more software plays a predominant role at ASML. Currently, I would say that we are more of a hybrid hardware-software company. The machines are to some extent still the superstars. They are also like mind-blowing pieces of engineering. But software is also of an equally important factor, especially because we approach the limit of what is physically possible as detected by nature, and then it becomes more economically viable to solve certain problems in software versus expensive hardware. So software, where we are here for today. So I'm an engineering manager. This story is a bit about leadership. How do I keep my team stable? But we are all leaders, right? So it doesn't matter if you're an engineering manager or if you're an engineer or on a team trying to convince a team of a certain direction in solving a bug, or an architect trying to set a certain strategic vision. We are all leaders. And what I'm looking for in a software team is this. Anybody want to guess what the picture is about? Oh, that's a good one. Doing the work that nobody wants to do. No, for me it's a good one because it is definitely also involved in the work. But for me it's about craftsmanship, right? So from your developers, from your teams, from your peers, you want to see craftsmanship, and I really like this example of craftsmanship, right? So if you look at the smith forging the katana, an ancient process forged to perfection. It's an elegant object. It is an effective object. It is for me a really nice analogy of what I like to look for in my software teams, right? So I don't want them over engineering, but I want them to craft high quality solutions, efficient, effective solutions. What I really like about the example of the katana is that craftsmanship is not only about creating something nice, but it's also about identifying with your work, right? So craftsmanship for me also equals to pride, right? So I remember 2 companies ago I was introduced to a project as engineering manager, and I show me some code. Did a lot of development myself, so show me the codes. And I said, let's rather not show you this code because it was hacked together and a lot of pressure, blah blah blah. It's of course a red flag, right? It's not where you want to be with your software team. So we want to see craftsmanship, right? A person who practices a craft with great skill. An example I like, and I'm a bit old, so a picture from 1984, which for me is an excellent example of craftsmanship in software, hardware engineering. So I think we all recognize the original 1984 Macintosh. Does anybody know what is special about this machine? Indeed, it was the first machine with a graphical user interface. Xerox had one also at the time, but it was really positioned differently. If you pull off the back cover of the machine, you will see the autographs of the full product team working on that machine. So if you ever talk about an example of the engineer as an artist signing his work, this is a perfect example, right? Every single engineer, every single member of the product team involved put his signature on the actual machine. So we recognize the top autograph. Anybody want to guess the other one? Wozniak. Ah, of course, there we go. Very good. Steve Wozniak, right? The actual engineering mastermind. Also in lithography, you see the same thing, right? So the first CPU by Intel, the project lead, Federico, he also put his initials on the on the chip. This is an early prototype. In the production run, I think they moved the initials because there was some interference, but it's a really cool example of craftsmanship in hardware engineering. Of course, also talking about software engineering, you like to see your peers or your engineers writing code like they're writing a book, right? It would not hurt that it looks nice. Maybe I'm not going into the subject of commenting code because there's a gazillion of opinion, but yeah, maybe if you write a complex algorithm or something, it's nice to put some inline codes here and there. So write your code as you write a book. Right, so now we have this situation in which we have a rockstar development team. How do we keep the band together? Right, because this is not a very sustainable model, right? You cannot put them on a leash, you cannot put them on shackles. Of course, this is something you never ever want to do. So it's a fact of life. People will join your company and people will leave your company. People will join your team, people will leave your team. The goal is, how can we stretch the time, right? So you need to invest in your people. So if you make sure that people, while spending time with your team, when spending time at your company, at your department, advance as a professional, as a person, and you make sure that they are happy, you can extend that time. Now, the key question is, of course, how are you going to do that, right? So you want to have them, if they ever decide to leave the team, that they are a promoter of your team, of your company. Like, okay, for me it was time to move on, but I really learned something at company X. I had a great time. I highly recommend it as a place to work. So this ties into motivation. And obviously we know extrinsic and intrinsic motivation. And you want to move from extrinsic to intrinsic. Now, I'm not saying that some of the extrinsic things are not important, because if you rent a place and you go to your landlord and you say, like, I'm the most intrinsically motivated developer ever, I said, that's cute, go away, right? So I'm not saying that money is not important. I would not advise you to make it your key driver in life. Look at things that align with your passion, with your the things you love, with fun, with what drives you, with make sure that you learn, right? That you have self-knowledge. And then there's an interesting book by Daniel Pink, and he tells us that if you want to bring these intrinsic motivation topics together, you should focus on autonomy, mastery, and purpose. And if you focus on these three, that productivity will go up. And it's the number one ignored fact in management, right? In leadership. And there's a very good reason for it, because it's incredibly complex, right? Because intrinsic motivation involves soft skills, right? And the soft stuff is the hard stuff. It involves maybe having semi-awkward conversations with a peer, with a teammate, like, oh, why did you do what you do? It makes me feel as such and such. So please explain. So the soft stuff is the hard stuff. So we have this model of these autonomy, mastery, and purpose pillars driving craftsmanship. And of course, you read a book and think, yeah, but I also have an opinion. So we add a fourth factor, which I will elaborate later, if time permits. Yep, time does. So quickly moving over the autonomy, mastery, and purpose. The autonomy, of course, is the urge to direct, right? So I often ask my developers in the teams, do you consider yourself a pawn or a player? A very simple question, a very important question, right? Because it should be the latter. We hire highly intelligent individuals, set the right context and get out of the way, right? And they will decide the direction. Autonomy massively feeds creativity. So I was when I was interviewing for the engineering position at ASML, one of the questions was asked, how did I operate my previous department of 120 developers? How do I control it? And the answer is, I don't, right? I hire the right people, I set the context, I set the expectations, off you go. A very important remark is, of course, there, success buys you freedom, right? It's not that you go off and sending people on their own. You always need to be there to kind of have their back. Mastery, the desire to get better and better. It's about the continuous learning journey, right? It's not about mastering COBOL and spending the next 40 years writing COBOL, right? There's new frameworks, there's new libraries every day. How are you able to master? How are you able to train yourself to continue to master these new technologies? Then there are four key sources we identify to learn, right? So you have the events as we have today. Of course, there's online courses and content. You have your social network, enterprise network. You have your partners you team up with as companies. But there's a very important fourth key source from which we learn, or how we learn. And I'm looking for the answer. Colleagues, a good answer, but for me it's under the social networks, under the networks we have, but a very good one. Anyone else want to take a guess?
Failing.
Oh, very good. Failing. And you fail by doing, right? So now I can skip the next 4 slides because you already gave the answer. No, just do it, right? Because by doing, you will indeed fail, right? And failing, I have like this hate-love relationship, right? I'm a perfectionist. I want to do perfect stuff. But if I look back at the previous 20 years, when I learned the most is when I failed the hardest, right? So failure is not a bad thing, right? Embrace it. There's an interesting book called Fail Forward, right? So fail often and fail hard. With an important science remark, don't do stupid stuff, right? So respect the customer value, respect the value stream. If I plot it on the semiconductor field, once a production process is up and running, and the chips are being manufactured in a high volume manufacturing environment, the golden standard is, if it runs, don't touch it. Another important part of mastery is the tooling, right? So a proverb is, a poor craftsman blames his tools, which to some extent I can agree with, but if you provide him with excellent tooling, he will get more stuff done quicker, and he will be happier, right? So decisive mastery requires excellent tooling. Which brings us to the third pillar, purpose. So what we do to serve something larger than ourselves, right? So for me, on an agile software team, the product owner is an incredibly important role, because he or she explains to the team why we are doing what we are doing. Right? So product owner is very important. Also, the mitigation of technical debt, of course, is very important. Also always an interesting balance between the two. Purpose is important because it helps focus, and focus is incredibly important in nowadays world, because information moves at an ever faster rate of pace. I read an article in Time quite some time ago already. It was called "Focus is the New IQ," and I couldn't agree more. So I highly recommend to read that article and share it with your team if you don't already know it. And also there's a really interesting book called Deep Work by Cal Newport. Highly recommended. It will be the challenge for the next decade. Focus is the new IQ. So purpose and focus together provide guidance to the people at the bottom, most important layer, making the decision where the information is. So then we come to this all-important alpha factor. And I, again, have a question. Who dares to guess what this will be? What do we need to add to autonomy, mastery, and purpose? To make sure that our developers stay as long as possible. Any guesses? We just learned that failing is a good thing, so. Sorry? Success is good. Success will come if you apply all these fours. But, yep, in the back. Recognition is a good one. But I like it a lot, but it's not what I'm looking for. Sorry? Relieve this pressure, fend off the team from all the management bullshit. That's a good one. I like that as well, but it's also not what I'm looking for. A good team? Yeah, that's also a good answer. But it's not the answer what I'm looking for. I will give you a tip. Excellent, indeed. So it's ultra trivial, but the fourth critical factor is happiness. It sounds super corny, but it is incredibly important. And it's also not always easy, because we learned that the soft stuff is the hard stuff. And with happiness, I'm not talking about how are you doing? I'm doing okay. This is not the answer we are looking for, right? Okay is not good enough. So when I have the one-on-ones with my people, the first question I ask them is, how are you doing? And they all know, because I all share this story with them, is that if they answer okay, then there will be a lot of follow-up questions, because we need to find out why it's not the other answer that I'm looking for, right? So we are looking for bringing together autonomy, mastery, purpose, and happiness to get people to that far right dark green part of this diagram, the actively engaged people, right? So you have a large light green part in the middle, the not engaged people. How are you doing? Yeah, I'm doing okay. I exchange some time, I get some money. Yeah, it's not too bad. And you have the bottom part, actively disengaged. How are you doing? Shit. The company is shit, everything is shit, my colleagues are shit, the developer infrastructure is shit. I would love to work with a MacBook, but they provide me this stupid Windows 10 device, and it's locked down, I have no local admin, blah, blah, blah. So why do you still work for the company? And then there's no answer, right? So you see in management and in leadership, a lot of people focusing on the dark green part, because that's where your superstars are, right? And not enough people focusing on the gray part. Like, why do you still work here? Is there something I can help you to get you maybe to the light green or to the dark green part? So as an engineering manager myself, I try to aim at a 50-50 balance between light green and dark green, because you cannot always be super actively engaged every single time. Maybe there's something going on in your personal life. Maybe there's something wrong with your family, or there's challenges with the kids or your relationship. I don't know, right? But let's aim for I try to aim for a 50-50 split. And they say, yeah, Apple, but this data is 10 years old. This is data from last year, right? So we're looking in Europe. This is, by the way, from the Gallup Global Workplace report. It's currently about 14%. So here you see like 24% is disengaged. In Europe, typically it looks more like 10-80-10, right? Or now it's maybe 14-70-14-ish, right? So how will you get your people, at least in the light green, but preferably most of the time in the dark green, actively engaged part? And this is very much about an emotional connection to your workplace. And the emotion is very, very important to me. The word emotion, literally from Latin means to be moved, to move stuff, get stuff moving. But emotions can also be awkward, right? It can also be a bit uncomfortable. So there's 6 things that I try to do to make sure that people are emotionally connected to their work. And the first one is make sure people are connected, that teams are connected, but also inter-team there are connections. That they build communities, that stuff is always inclusive. And I know that inclusive is kind of a buzzword, but it's a really important word. So we employ people from all over the world. Some are extremely religious. Some recently changed gender. How will you make sure that the two will unconditionally cooperate and also trust each other at an emotional level? So connect people, build communities. The analogy I love to use for a team is compare it to this medieval wall. And I 3 years ago went with my wife and the kids to the UK, and we had a final stopover at Dover, which for me always was this super depressing place, which it's always cloudy, but that was a beautiful day. And actually there's Dover Castle. I highly recommend you to visit it. It's beautiful. And at Dover Castle they have this lighthouse from the Roman era. So it's like over 2,000 years old. And I told my kids to just touch it and feel it, right? It's been there for so long. And if you look at that tower, how it's constructed, it's a pile of rocks, right? So for me, the developers are the individual rocks. All have different sizes, different shapes. And just the rocks do not give you a solid structure. It's the mortar in between that gives you a strong structure. So for me, it's all about the mortar, not about the bricks. And the mortar, for me, in a team is the social glue you have, right? The social connection. So that's why, for me, it's incredibly important that the development team, not every Friday, but on Friday or sometimes that they also have social events. And they go to a park together, or they have dinners together, or we have an annual barbecue at my place, and we invite all the developers, and bring your family and bring your kids. Right? So the social connection is incredibly important for me in a development team if you want to get it to the exceptional level. The second reason is obvious. Be fair, of course, right? Because if you're not fair to people, then it will be not good. No bueno. Empower professionals with autonomy, right? So you hire a highly intelligent individual. Do not constrain them too much with processes, right? So provide them and empower them with autonomy. Yes, they will fail. My approach to this is if they fail, if my team somehow, if one of my teams messes up, I will go to the project lead and say, I messed up. I will go to the director and say, sorry, I messed up. If they do an exceptional thing and overachieve or overdeliver or find a brilliant new algorithm or they achieve some nanometers for customer X or Y, I will go to the same director and the same project lead and say, look what the team did, right? So I take blame and I give credit. And I think that as a leader is a very powerful way to empower your professionals. The autonomy also works in the roles we have in the team, right? So I try to encourage a lot of lateral and longitudinal flexibility in the roles we have, right? So if a developer wants to experiment with a lateral movement in his role, we're always up for it. If they want to be involved more in integration issues or architectural issues, we always support it. Do they maybe want to move from a developer a bit more into a scrum master or an engineering manager or a project lead role? Let's discuss it and we will make it happen. And we will trust that you will be awesome at it. So also, if you have this highly intelligent knowledge worker, then make sure you challenge them with a matching context, right? So give them a complex task to do, because that will be much more satisfactory to complete. And inspire them with purpose, right? So again, the product owner, very important role. Why do we do what we do as a software team? So make sure that there is a mutual understanding of the significance of the purpose that we are working on. And that is a challenge, right? It will not be easy, but we will succeed and we will overcome. And then the sixth one, by far the most important one, ensure physical and psychological safety. As a leader, as a peer, make sure that your peers or your team members are always feeling safe. So often when adding a new developer to the team, you have an entirely new team, right? So you have 5 or 6 people and you add one, it's an entirely new team. How will you make sure that that new person feels warm and welcomed and feels safe from the instant that they join the team? Because experience is often mistaken with intelligence. right? So if you add someone to a team, they might have bright and fresh and new ideas. But what if the environment is that they think, oh, it's a bit intimidating. For me, the next 6 months I will shut up and just watch and learn and not speak up. Then 6 or 5 months are lost of a brilliant idea, right? Also, with the multicultural aspect mentioned earlier, make sure you hire the people or include the people in your team with a team's first mindset, right? It's not about the individual, it's not about the local hero, it's not about the rockstar developer. It is about the, it's always about the team. So if you take care of these 4 pillars and these 6 pro tips, then you will have a team that will is not doing okay, but they are doing great. And that's what you're looking for. And that's also the answer to the question that I'm looking for. If I have the one-on-one with my people, the answer I'm looking for, how are you doing? I'm doing great. So that was my more or less monologue I prepared. Any questions you have for me regarding this? While I lubricate the vocal cords. And if not, then I assume it's a good story. And I hope you enjoyed it. Any questions or remarks or challenges? Yeah, please.
Do you succeed in keeping enough people in because you have a lot of work, a lot of customers?
The question is, do I succeed keeping the people in while under a lot of pressure from customers, right? Did I?
Yes.
Yeah. The answer is yes, kind of. I'm going to be very honest, right? So we do have attrition at ASML, but it's low. The main competition we have is from US companies in Amsterdam, right? So we see developers leaving in that direction, but it's manageable. But yeah, there is some attrition there. It is not to the extent that it significantly impacts roadmaps. So yeah, does that answer the question?
Yeah, it does.
I would like to hear how you prepare for generation C and alpha, the employees at your company.
Yep. So how do I prepare for generation Z, I think you meant?
Yes.
Yeah. And generation alpha?
The next one.
Okay, I didn't know. Yeah, that's a really good question. How do we prepare for generation Z? That's the next one after millennials, I think, right?
That's the next one after Y. I guess you're an X and I'm an X.
Yeah, I'm my year of I'm a 76. So how do you prepare for the specific demands of the millennials and the generation Z? I'm a bit reluctant to answer because I look at it more at an individual basis of what do I need to add to a team at what point in time. I think for sure the stuff we just talked about, autonomy, mastery, and purpose, is especially applicable to some of the younger generation. They're really looking like, okay, how am I going to contribute, right? So ASML is quite an industrial environment, which sounds a bit cold. Yet, the solutions we provide have a massive contribution to sustainability. Then how you position yourself as a company, embracing neurodiversity, for instance, any kind of diversity. I think that will be the stuff that we do to make sure that those people also feel at home, they feel welcome, and they are happy, right? I don't really like the generation X, Y, Z kind of putting people in boxes, but does that kind of answer the question, or?
Yeah, it does.
Yeah.
It's about your company identity.
Yeah, I see that. At least that's what really important. So also with the working from home, it depends a bit from engineering manager to engineering manager. But for me, I don't care, as long as the work is done, right? So success buys you freedom. That's an important remark there. And we have seen in the very first months of COVID, massive lockdown, that there was no impact on development team output. And if there was any impact, it was a positive one. Now you can put a lot of side marks in there because also some unhealthy stuff happened, but all of a sudden people have 10-hour work days because they love their work, right? So it's also a good thing, but also, yeah, we are under a lot of pressure to deliver, but still you actively manage a work week to be within 40-ish hours, right? So, yeah, again, the autonomy part is a really important part in there. Yep. All right. Any other questions? No. With that, then I thank you for your time and for the interaction, people. Thanks. Thanks a lot.